Hello, Jessica. Doing good. How was your weekend? Good. Okay, let's start. So, have you? I think I haven't given you much homework, right? Last lesson I haven't sent notes. Oh, okay, my mistake. I will send today with that. Okay. Okay. I'm sharing my screen now. You see my screen now? Okay, cool. So let's start today's lesson. We have done. Okay, let's do. Okay. Now we are moving from our like last session. We did our 5 exercises, right? So today, let me put my date over here. Today's today's date is 27, 29, right? 29, 2025. Okay. So now we are going to do some of exam questions that has been labeled as kinematics, and they have asked, they have been already asked in the past exams, right? So first question, if let me find that question paper. Let me do a new date for today's. Every day we will do a date, new date, right? It will be easy to. I will put date, new date over here. Hmm. First question is from free for 2022. Which one will be? Okay. So let me relate this question. What I had released from above table, calculate the time to fall another ball, half the mass. Sorry? No, no, I'm just matching the question that I have extracted. from the actual question paper. So if you can see now, is it, you see the question paper now? It's on the same. Oh, oh, just a second. I think it's get jammed. No, just a second, please. I think it's my setup that has passed up. Okay, let's close this one. Okay, and let me close this call and I'm calling you again. Okay. Yeah. Okay. So let me share the screen again. I am sharing entire screen. Okay, let's see entire screen share. Now you can see my screen. I did it, and let me open this one. Now you can see, right? Okay, let me see if you can see both at the time. So this is the question paper, and this is the. Can you see this one as well? Okay, cool. So yeah, so I just want to check that the question that I've accepted is the same or not. So it looks like the same, right? So just to show you the diagram, and then we can try to solve it. So the question says a steel ball is held 40 centimeter above the table. So this one is the height above the table. The ball is released and the time for it to fall to the table is measured. Okay, so it's to reach here. Okay, calculate the time it takes from the ball to fall to the table, and then the experiment is again repeated. The experiment was repeated with another ball of the same size but half the mass. Ignoring any effects of air resistance, use physics principles to explain how the time of this second ball to fall compares to the time of the first ball to fall. So we have to compare these both, right? And then final velocity, what assumption you have made. Sign directional listening ball. You should start by showing the horizontal velocity. Okay, so let's give a try to this one. All right. So let's begin this one. 29, 2025. Okay. Now there is exam questions. Exam questions, and the first question is related to free fall, right? So the concepts that we haven't covered in our theory, we will cover in solving these questions, right? Okay. Now it says there is a table, right? And ball is released 40 centimeter, 40 centimeter. So zero point 0.4 is 40 centimeter, right? So from here to here, it is 40 centimeter. Above the tail, calculate the time to fall. Now, in this problem, we know the displacement. So we have the displacement. Let's put it here as equals 40 centimeter or zero point 0.4 meter, zero point 0.4 meter, right? The acceleration. Now, here the acceleration is positive. As we have seen that we throw the ball, it is negative because it's going upward, but the acceleration is pulling it downwards, right? So it was when we are throwing the ball upward, it is not acceleration, it is deceleration, right? So, or if we're saying acceleration, it was in the negative direction, but now the ball is free fall. So the direction of the movement and the direction of the acceleration is of the same direction. That's why we are taking as a positive, right? Yeah. So it's 9.8 meter per second square. Yes. So it is basically what it is eventually. So it is eventually uh, gravitational acceleration. So it's Earth gravity. Uh, Due to Earth gravity, the free fall accelerate downwards because it's attracting the ball towards downwards, right? The scientists have already measured that what the acceleration is. It's 9.8 meter per second square, right? So if the ball or any object is um moving from top to bottom, it will be positive. If it is moving against the gravity pull, because gravity pull is always in the downward direction, so if it is moving upward, so it will be like in the negative direction. The acceleration will always be in the negative direction. All right. Okay. So acceleration is there, and we know that the initial, again, because it is released, that means it is on the rest, from the rest. It is from the rest. So yeah, so it will, the initial velocity will be 0. So this will be the initial. Yes, because it stopped, right? So let's say, so the equation which relates these two, and what we are going to find, the time, right? Calculate the time to fall. So that will be t we are going to find. So now it's just the matter of time that we have to write it down the equation ut plus half a t square, right? So let's do it like that way. put in the values. Zero point 0.4. Now why we are using zero point 0.4? Because acceleration is meter per second square, right? So that's why we are using zero point 0.4 is equals to u times t. So u is 0, right? Plus half of 9.8 t square, right? So this will be like this. So now I'm changing the RHS to LHS, okay? Because the subject is on the other hand. So we are taking the subject 9.8 by 2 in one bracket, okay? Yeah, that's for the half 9.2. So I'm just clubbing them in one bracket, okay? And is equals to zero point 0.4. So we can solve it in both ways. If we can say that, okay, let's see, t square equals to zero point 0.4 times 2. So this will come in here, right? Because this side, so for example, a small algebraic rule, a over b equals c. So it will become a equals bc, right? So this b is multiply this side. If this is divisible in the denominator in this side, other side it will become the denominator. Okay, so it's something like what I did from here to here is the same concept, which says multiply b from both the sides, right? So if I say multiply b from the other side, so this will becomes c a over b, right? Equals c b, right? So this b will be cancelled out, and a will become bc, right? So this will be the same effect when it's just like moving b from denominator to denominator on the other side. No. I times b from both sides. So this time b and this time b, right? So the question says if a over b is equals to c. So this is the initial way, initial question, right? So now I'm timing b on the both the side, right? So this b will be cancelled out from there, and then it will result as a equals bc. Now get it? Okay, cool. So this is what I'm doing here. So because this 2 is in the denominator at this side, I just make it a denominator on the other side. And again, the same rule applies from here. If 9.8 is as a denominator on the this side on LHS, on the if we are moving to RHS, it will become the denominator. So I'm just putting at 9.8. Cool. So then t will becomes root. So because this is square, we had square root from both the sides. So it will become zero point 0.4. Now you have to calculate for me 9.8. Now tell me the result. Okay, that's cool. So 0.29 what? Yes. Never forgot that. Okay, so that means t equals, now we have to write it down in the sentence that the ball takes about 0.29 seconds to hit the table. Hit the table. Table. Cool. So in this way, the same way that we have solved the previous questions, like these ones, right? We have to just see that what has been given, what has been asked, what will be the appropriate formula that we are going to use, and use the simple algebraic expression to solve that equation. Okay. Now, the second question was another ball, half the mass is released from the same height. Compare fall times. What is happening here? The second ball has half the mass, but the only factor in the equation are displacement, acceleration, and time. Mass does not appear in the kinematic equations. So the fall time will be the same 0.29 seconds. This shows that in free fall, ignoring air resistance, all objects accelerate at the same rate. This is Galileo's principle of falling bodies. Okay, so you have to remember that to answer the question B, you have to remember this, that in free fall, so there are two things that we have to consider: free fall. The second one is ignoring, yes, ignoring air resistance. Right. So in free fall and ignoring air resistance, all objects all objects accelerate accelerate at the same same rate. Yes. This is Galileo's principle of falling bodies. Right? So there is a video in YouTube of explaining the same concept in, because at the Galileo's time there was no such technology of vacuuming the whole big chamber, but people are doing some experiments since then, that they took a heavy metal ball and there is a feather, right, a lightweight feather, and they release at the same time, right? So, according to Galileo's principle, they should touch base the ground at the same time. And that's happened actually in that particular video. I will look for it for you and I will send to you. I believe it's from the Mythbusters, the YouTube channel, the Mythbusters. So they have explained it in very detail this concept. So just to remember and have a much more clarity, you can watch that video. It's a great explanation, but to give the answer, you have to remember that in free fall and ignoring the air resistance, mass doesn't play any role. So that's the thing that we have to taking account. Okay. Now Question paper 2023. Let's see if I can find that too. I have saved that somewhere. 2023. Can you see that? Cool. Okay. Now the question extract is question 2, A and B. So a softball player accelerate from rest to this. Show that her average is in this. Calculate the displacement over this time. Okay, let's do something over here. Where is the question paper? Okay. The diagram shows the layout of a softball game, right? A stationary player accelerate from the home plate to first base, from here to here, right? The player takes 6.61 second to get to the first base and arrives moving at 5.45 meter per second, right? Show that the average acceleration is 0.825 meter per second square. Calculate the maximum displacement between the home plate and the first plate. Why might it different from the actual distance traveled by the player? We will look to it. Okay, there is an impulse we haven't studied yet. Catching the ball using a relaxed arm and a padded glove. Okay. Collide and stick together and move to the right and after the collision. That's also again some other concepts, but this is related to collisions, right? Uh, this is relating to law of momentum, conservation of momentum law, right? So that's not okay. That's good. So that the other two part is our concern at this moment, right? So do let's complete these two questions and then we will move to the other one. All right. So let's take the question number. mm, Question 2. This is related to paper 2023. Question 1, A and B. Right? Okay. The question says, now let's list up what the question is. A softball player accelerate from rest. See the keyword? Yes, from rest to 5.45 meter per second in 6.61 seconds, right? So there are like two ways to write it down the units. Here you have seen meter per second. I can also write it down as meter times second inverse. Meter time, oops, second inverse. Oh, it's too hard for me. Okay, so you can get the gesture that this is meter per second and this is meter inverse. Okay, so now the question says we have to calculate the average acceleration. Average acceleration. Right. So what we are looking for? A. What we are looking for? A. What is given from rest? That means u equals 0. We have time, that is 6.61 second. And then there is a final velocity, which is 5.4545 meter per second. Now we have, because we have AUTV, that comes from our first equation. V is equals to U plus AT, right? U plus AT. That will be good. So now we have to change the subject because acceleration is asked and acceleration is in this side, right? So what I'm doing is, let's do this one is, uh, I'm just changing LHS. Now what the first step will be? Changing the, or interchanging the LHS, right? No, no, no. So I'm just first interchanging the right hand side to the left hand side and left hand side to the right hand side, right? This will be the first step because the subject is on the right hand side, right? So now this will become U plus AT is equals to V. Cool? Now, first is we are, let's say, if you are comfortable with doing like that, we can do subtracting u from both sides, right? So now I'm subtracting u, uh, let's say u, I'm subtracting u from this side, from the LHS side now, and subtracting v, u from the RHS side. So u minus u becomes 0, plus AT gives us V minus U, right? So now we need just the A. So what we are going to do is dividing both sides by T. Okay. So let's dividing by T this side. Let's dividing T by this side. So this T will be cancelled up and we will get our A equals V minus U T. Cool. Now we have our all the, oops, okay, oops, just a second, kiddo. हाँ हेलो. हाँ. ਕਿਹੜਾ 에ਅਰ ਪੰਪ? ਯਾਰ ਉਹ ਮੈਨੂੰ ਲੱਗਦਾ ਹਰਵੀਰ ਲੈ ਕੇ ਗਿਆ ਸੀ ਇੱਕ ਵਾਰ. ਹਮ, ਸ਼ਾਇਦ ਨਹੀਂ ਤਾਂ ਉੱਪਰ ਕਿਤੇ ਪਿਆ ਹੋਏਗਾ. ਹਮ, ਆਈ ਥਿੰਕ ਸੋ. ਹਮ, ਠੀਕ ਹੈ. ਹਮ, ਹਮ. Okay. So now we finally have our um, the equation. Now the only thing that we need to do is put the values. We have A equals V, that is 5.45 as 0 perfect over 6.61, right? So if you do that calculation for me, 5.45 over 6.61, we will definitely get to the answer which says A equals, sorry, 0.825. Sorry, yeah. So in that case, it will be like, because the question that has been given in the two places, so we can answer it as either 8.2 or 0.82 or 0.83, right? So because the question they have asked is for this one, right? So that there are, yeah. So we have to make sure that we can say that, okay, this is the exact answer, 0.825 meter per second square. All right, so this is the first step that we have given. Okay, now we have A, we have U, we have T, and now we are looking for our displacements. Right, we are looking for displacement. So mostly we are using this equation as equals ut plus half at square. Again, the s will be u, t is 6.61 plus half. A we have just calculated as 0.825, and t square is t 6.61 square. So can you calculate that? Eventually this will be like, yeah, so it is 0.825 over 2 times 6.61 square. Sorry? Yeah, that will be like, they will give, it will gives a sense that 6.61 square. So if you can calculate 6.61 square first, then there is no need. So in the calculator, you can do it something like this, 6.61 square, right? Times 0.825 and then divided by 2. You get 0? No, no. So 0 is here, up till here. Plus, okay, I bring, let me bring my calculator and see. Okay, this one is, can't we have both? Uh, yeah, so that's the what we are looking for. Okay, cool. So that will be is equals to 18.02, or it will be 18.02 meter, right? So here displacement is 18.0 meter in a straight line. In reality, the actual distance might be slightly longer because runners curve around the bases, but physics calculation are based on straight line displacement, right? So if we look for the question, where is the question paper? So if we can look for the questions, so runners will like going from this point to this point, right? So it maybe not be like let me come up with the notability. So there are 2 points. So let's say this is a box, right? And this is another box, right? So we have to calculate from this point to this point, right? So this is the displacement, but runners actually run in a bit, like you can say, because there is a slightly chance that they are standing somewhere over here, right? Not the actual patch, right? So it will be like something from here and they will not stop here. So there will be a slightly more, not more. But if they have asked the question, then we have to mention that because of the straight line measurement, the displacement in straight line, in straight line. So the actual runners will have a bit longer curve. Okay. Yeah. Because with a meaning, because if they have asked, so let's say the question is uh, calculate the calculate the maximum displacement between the home plate and the first plate. So that's the maximum displacement because we are looking for the straight line, right? Movement. Why might this displacement be different from the actual distance traveled by the? So because they have asked this one, to answer this, we have to mention that, right? The actual displacement. So now see the difference between what they have asked, the displacement and the actual distance, right? So this will always be different. That's for sure. The reason behind is the displacement is calculated in the straight line, but the distance actually traveled can be in the curve path. Okay, so you have to mention that too. So that you can show that you know the difference between the displacement and the distance. Right? Cool. Let's move to the other question. Let's see. Question 2022. Okay, C and D part. Just 2 minute break. All right? Yeah, just coming. मेरे बच्चे and you're the cool uncle. Where they are? हेलो जी। Don't you want to see your nephews? क्यों क्लास कर दी? Your nephews. चलो रेडी बंदे। देखो देखो। कितने लगे जस्ट सोने हैं बहुत क्यूट है इधर बोला देखो तो सही वाला मम्मा फुटबॉल खेलने जाना है छोटा हो गया यार बहुत चीज तो क्या okay uh, you back all right so we will discuss these questions projectile motion because we haven't studied these before. So what I would like to say that we can do it by simultaneously, right? Uh, let's find out the question 2022 and then we will move to this one. So this is 2022. This is the C part. Okay. Now, there says the steel ball is now rolled along the table and off the edge as shown. The height of the table is 70 meter and the ball hits the ground 1.8 meter past the edge of the table. So this is the total travel height, right? So now they have asked calculate the ball's final vertical velocity. What assumptions you have made, right? And the second question is calculate the size and direction of velocity of the ball just before it hits the ground. You should start by showing the horizontal velocity of the ball is 4.8 meter per second square. Okay, so there are like three type of questions can be asked when we are dealing with the projectile motion. I will tell you something. We will do some in detail the projectile motion separately. But to give you a hint, I can mention here as a projectile motion. Yeah. Yes, 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 yes. Definitely, definitely. You know very much, right? You just feel very nervous while solving the equation, but you no worries, no worries. So you know the basic sense now how to rearrange them? Good. True, true, true. I will give you some algebraic as I promised, but I haven't given you a thing, but still. Okay. So now projectile motion. So we have already done like three type of motions. Basically, one is the linear one, right? The second one is free fall, right? Free fall. And the third one is our projectile motion. Projectile. Yes. So all these are based on that uh, motion equations, like kinematic equations. So first is in projectile motion, A, it will be something like this. So the object is at this end, right? And it will go in this path. Mm, in this path. Okay. So this is the first kind of projectile motion. The second one will be the second one will be we are at a certain height already, right? Let's say we are here at a certain height, right? And from here we are throwing it or kicking the ball in the projectile, right? And the third part, oh, yeah, all the we will discuss all the three cases separate in detail, but I'm just giving you a hint that what is expected and how we can go to with them. All right. So the third kind will be something which is being, as you have seen, that there will be some height and it will be like rolled up. Uh, yes, right. So this will again a height, right, and object is here, and the object is here. So it will take some time to reach over here, right? So these three type of motions that we are looking at when we are dealing with projectile motion. So this one is a straightforward from here to here. There must be some displacement s. There must be some height, right? Right. Then we have now considering these three motions. Let's consider these three motions one by one. So in topic A, so all these three projectile motions, for all three projectile motions, there are things that we need to remember. The pen. केड़ा pen? Football का. अच्छा. If not, it's fine. Then you can be.
In total, 8 to 9 inches. हाँ. 8 to 9. 8 to 9 inches. It's okay. I have read so much about it. I'm reading from a book. It helps them to speak English. My books are there. I'll just pick a random book.
Sorry, Jessica. I have to. My son, he want to pump his football, and he was looking for a pen, and I remembered where I put it there, but now I can't find it. You know, when you put something important thing at some special place, and you forgot that place. Yeah. Anyways, so what we are going to do in the projectile motion. So you think you know that what type of projectile motion has been is to be expected, right? All these three types, mainly these I can say. And in projectile motion, one thing that we have to make a note is we have to do is the horizontal. So firstly, there will be like two component of velocity, right? So you know this, I believe you have seen this before, right? There will be a V cos theta. This will be the actual V, and this will be V sin theta. And this is the angle theta, right? So what I'm saying is in projectile motion, we have two components for velocity. Get it? Components for velocity. One is horizontal, and the second one is vertical, right? So that will be uh, uh, denoted by V cos theta, and that will be denoted by V sin theta, right? Second thing is they are independent to each other, right? They are independent to each other. So there is no such like a thing that can affect these two components can be like we can use them separately, right? And the second thing is the next thing is there is no acceleration in we can say uh, yes. So these are these are even though there are they are vector quantities. What I mean is the horizontal motion is a constant velocity, right? And And to solve these kind of equation, we need to understand both all the three equations perfectly, so that we can use them to calculate one thing in one motion, and the other thing in the other motion, right? Uh, I'm talking about vertical and horizontal motion, right? So in horizontal motion, or horizontal velocity, that's a constant. Velocity is constant, right? We can say constant, constant velocity. Yes, velocity. The horizontal velocity will always be a constant, right? So now the thing is that to understand now all these concepts we are going to use in our calculations, right? No. To get the normal, yeah. So to get the normal velocity, what we are going to use is the trigonometry. Okay. Yeah. So let's say, and there is other thing. Let's do that thing first. Then, okay. To calculate the actual velocity, if we have, so there is a rule for the vectors that we can interchange the tail and the head, right, of the vectors. So as we know that we can represent the vector quantities like this. So this is actual V. This is V. I'm saying Vy, right? And this is Vx, right? What is V? V is the actual velocity. Actual velocity. Vx is horizontal velocity, or horizontal component of velocity. Horizontal component. Okay. And Vy is going to be our uh, vertical component. Vertical component, right? Or velocity. Okay. So when I say that we can move, and if there is like this is theta, we can say, if we know the angle, right? Then only we can say Vx is equals to V cos theta, right? And Vy equals V sin theta, right? Okay. So now the thing is that as I said, that in vector calculation we can move one's tail to other head, right? From this tail to this head, then what we will get is, this is our actual V. This is the Vx, right? This is our, Vy, right? So you see that, what you can feel that this is a right angle triangle, right? So in right angle triangle, what we know is the hypotenuse square is sum of the perpendicular square the perpendicular square, and the base square. Right. So this is related to the Pythagoras theorem, right? That we talk about Pythagoras theorem. Theorem. Right. So we can now this is the what if we need to say that okay, what will be the final velocity? That will be the root square of vy square plus v, right. And if they are asking what will be the direction or what, so direction will be the angle, right? We know that the tangent, because if we draw this in our in any graph, there will be an tangent, right? The tan theta. So the tan theta for this, if we know the tan theta, and so because there is like vf vy y we have vy and vx. So if I say v sine theta over v cos theta, I can say tan theta equals to v sine theta over v cos theta, right? So v sine theta is vy and v cos theta is vx, right? So to find finally the angle will be, or the theta will be, the tan inverse of vy over vx. So that will be your complete answer. Yes. So this will be the velocity, the total or the composite velocity we can say. So let's say if we kicked it here, so to throughout what will be the velocity? So we have to find the x component. We will going to find the y component, right? And then we will do the, or if with some other information, that if they have given like the height or the distance, then we can finally calculate those things, and we can say that okay, finally the y component is this, x component is this, and then the actual velocity throughout the path or throughout the projectile is going to be this, and the angle of that will be this, right? No, no, normal velocity is this. So this, right. So this is the velocity. Okay. So let me write it down here. This is the velocity, and this is the angle or direction. Direction. Right. All right. So these kind of thing that may be asked, and this can be asked. If you're able to solve this answer, definitely you're going to get a merit. Sorry, not merit. It is an excellence part of thing. If this kind of thing, right? Yeah. So let's take an example. So the thing is, this demonstrate the independence of motions, that vertical motion accelerate under gravity, horizontal motion continues as constant velocity, together they create the parabolic path, right? So the thing that I missed, that I want to make it sure that the horizontal velocity is a constant velocity, and the vertical velocity is always under sorry, I will write it down here. Point number one. If you remember these things, you are going to definitely answer the question. Vertical motion, accelerate, accel- under gravity, right? Second point is horizontal motion, horizontal motion continues at constant velocity. Right? So these like point that you have to remember while dealing with the projectile motion is this alongside with the actual kinetic motion equations, right? So to implement these, remember this horizontal, this is vertical, vertical motion accelerate under gravity, horizontal motion continues at constant velocity. To calculate these things, we are using the Pythagoras theorem and the tangent. Okay, let's do this example and see if we can go with it. Okay. Okay. Let's see here. Okay. It's not a straight line, but we can deal with it. Now the question says, let's begin with the question again. A ball rolls off a table of height 7 meter, zero point 0.7 meter, and lands 1.8 meter from the edge. Calculate the vertical velocity before it hits the ground. Calculate the horizontal velocity of the ball. Right. So bring that table thing. So this is the table. This is the ball. Right. The table height is zero point 0.7 meter, and this lands from here to here is 1.8 meter. 1.8 meter, right? So we have, what do we have now? We have a displacement horizontally, and also we have a distance that need to be traveled is about zero point 0.7 meter vertically, right? So we need to find out the calculate the vertical velocity before it hits the ground, right? Vertical velocity. So before, so vertical velocity, now we are dealing with vy, right? First we have to find out the vy. We have, so now vertical velocity, so what is the vertical distance? That is sy will be zero point 0.7 meter, right? The initial velocity will, sy is the vertical height, right? So this is zero point 0.7. So that I just making synonyms, or I try to make the same notion for both of the for both of our vertical synonyms, or vertical motion. So we are using this height as a vertical distance or displacements that it has to travel, and we have to find out this. For you, sorry, for you, will be 0, right? And the acceleration is going to be the g, the gravitational pull, which is 9.8 meter per second square. So we do not know the time, we do not know anything else. We just know these three or four terms, right? One, two, three, and four. So the best equation which suits here is, can you remember where we have S, we have U, we have A, we have V? All these four quantities without the time. Hmm. Okay, let's. So, yeah, yeah. No worries. No worries. So VF square is equal to VI square, right? Yes, yeah. No worries. So it's just a representation of what the meanings of those variables are, right? So your equation is correct. So I'm writing it down here. V square correctly. You find it correctly. So now I have full confidence that you are able to solve these equations, right? So now I'm just putting these values over here. So we need Vy square is equals to U will be 0 plus 2as, A is 9.8 and S is zero point 0.7 meter, right? So this will gives us Vy square is equals to, uh, can you calculate 2 times 7? 100? Okay. You have to do it correctly, Ma. Okay, 2 times 9.8 times zero point 0.7. So that will gives us 13.72. So that will gives us 13.72. Then Vy will be root of 13.72, which eventually, let's see what we have in our calculator. Ding, scientific. So we can have root square of 13.72 is equals to 3.7, right? So let's put that. So 3.70, 3.70 meter per second, right? So now the second part. So this is going to be the first part. Question 1C, first part. And then, so this is of the year 2022, right? Question 1C1. And then we have the second part too. So to solve the second part, which they have asked, is calculate the horizontal velocity of the ball. So for that, because now uh, we can only see that if we want to calculate the time, we have, like, if we say Vy again. So let's say now we have Vy, right? 3.70 meter per second. We have A, which is equals to 9.8 meter per second square. And then we have U, which is 0. And we are going to find the time of the flight. Right. So now we have V, we have U, we have A, we need T. Which equation we are going to use? So that needs the T part, right? So we are looking for the T. And we do not have displacement. So we are using it V equals U plus, yeah, right. So we have now I'm putting it 3 point. Let's do something with the same. So now change because T is in this side. What I'm going to do is TAT U plus AT equals V. So this is the first step. We are changing the subject. Now replacing those values 0 plus AT. No. So now I'm subtracting U from the both sides, right? Minus U. So this will cancel it out. We have AT equals V minus U. Then we have, I'm dividing A from both the parts, from both sides, right? So this gives us, cancel out A, right? So this will give us T equals V minus U over A. Now we can put the values. We have 3.7 minus U is 0 over A is 9.8. So now we get the time of the flight is equals to 3.7. 3.7 by 9.8 equals 0.377, 0.38, right? So this is going to be 0.378 seconds, right? So now to get the horizontal velocity, where we know, so horizontal velocity. Here, because we do not know the acceleration, we don't know anything, what we know is the distance. If we have a constant velocity, so the equation says if we have a constant velocity, there the distance is equals to velocity times time, right? Where this comes from? Now you have to tell me if the velocity is constant, is this formula correct? Which equation is coming this from? Okay, no worries. So we have the distance, the displacement. We have the velocity, right? So let's say velocity, initial velocity. We have time, right? And we have also acceleration, but that's constant. So constant velocity means a is zero, right? Constant velocity means that if I started with 5 meter per second, after 5 minutes or 5 seconds, after 5 seconds, my velocity is still 5 meter per second. So this is a constant. So my velocity is not changing, right? My velocity is not changing. So not changing means my initial velocity is equals to my final velocity. Sorry, both reverse we can say. My final velocity is equals to initial velocity. It can only be possible when either a is zero or time is zero. Time can be zero? No, right? Time cannot be zero. So that means the constant velocity means the acceleration is zero. I'm making a note over here so that you can remember this. What I'm saying is constant velocity means acceleration is equals to zero, right? Okay, can I change this? Okay, so this I can point it out. Okay, constant velocity means acceleration zero. Okay, so in the same way, when we are saying using v equals, oh, sorry, in the same way, yep. In the same way, if I put this same thing, no, we had this one, right? Oops, what is my color, default color? Yeah, this is the color. So now we are saying that acceleration is zero. That means in this equation, if I put the same half a is zero, then t square, that means s equals ut, right? Equals ut. So this is distance or displacement, right? Is equals to velocity, because here it doesn't matter if it is the final or the initial, right? Because it both are same. So we are saying velocity into time. So that's where it comes from. In the constant velocity, sorry, in the constant velocity scenario, distance equals to velocity times time. So we have to remember that if we have to calculate the distance or a range, you can say, in projectile motion, we are going to use this formula. So in this formula, we have to know the velocity and we need to know the time. Then only we can calculate the distance. And we can see how we can calculate these things, right? So here, as we know, as we know from our equation, that this range is given as 1.8 meter, right? So by doing that, we know distance is equals to 1.8 meter. We know the time, how much time it took, even though we calculate the time from the vertical motion, right? Because both are independent, that means we can use the same time because it took the same time, whether it is the horizontal velocity or the vertical velocity, but it took the same time to reach here, right? So we can use the same time that we calculated from our vertical motion into in our horizontal motion equations as well. Okay. Yes. Time will, so for example, if a ball is going from here, from this end, right, going like this, so it will hit here in the same time, which is traveling this line. True, even though it's coming from this side, but it took the same time to reach here. Cool. So remembering that, we got the time as 0.378 seconds. Now we can say Vx equals distance 1.8 over 0.378, right? So that will gives us 1.8 divided by 0.378 equals 4.76. So that will gives us 4.76, 4.76 meter per second, right? So the ball's horizontal velocity is 4.8 meter per second. This demonstrates the independence of the motion. Vertical motion accelerate under gravity. Horizontal motion continues at constant velocity. Together they create the parabolic path. So what is happening? Once, for example, once a ball has been thrown, we have put some force over here. Will the initial force or initial velocity will be going to this side in the direction of the force. What is happening is the gravitational, there is a continuous pull on the downwards. So for example, if we took that thing, we looked at this motion, what is happening at every point, at every point, here, 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 right? Every point is, there is a vertical pull and there is a horizontal push. This is happening at the every point, right? This one is happening at every point. So at first, this height, up till this height, up till this the maximum height, right? Minimum height. So when it says maximum height, maximum height, That means the Vy will be 0. Remember? Because when we are throwing a ball from ground to the top, so what will the maximum height it will require? Yes. So once we have the maximum height, that means after the maximum height, it will come down, right? So similarly, when it is in a projectile motion too, the once the maximum height is where the what we can say, vertical velocity is going to be 0, maximum height at maximum height, right? At maximum height, vertical will be 0, and till the maximum height. So part, in this part, A is acting as a negative. So it is reducing, trying to reducing the speed, right? Because it's continuously pulling downwards, but the ball is not coming downwards. That means the acceleration is actually a deceleration. We are using minus 98. Once it achieved the positive, once it is achieved the highest, till this direction, the A will act because now it's coming downwards. So that means it is acting in the same as the acceleration, right? It's coming the same direction. That means in that direction, it will come as 9.8 meter per second square. So I will show you some questions related to the projectile motion in detail. All these three scenarios we will cover up. Okay. But to give you an idea that what the actually happening in projectile motion, this is the thing that we have to take care of and taking notes of it, right? And eventually, so for our actual question, what is happening is because it's already at the maximum height, right? So that's why we use A as positive. We have used A as positive here. We have used A as positive here, right? So, and there is an interesting fact. We will see later that for maximum for maximum range, the angle of projectile projectile should be 45 degree. So what has happened here is, so let's say we have this scenario. This will be the y. Sorry, this is the x-axis. This is the y-axis. So now we have three colors. One is, let's say, like this, where the angle is this, right? We have a lower angle like this. like this, and then there is a bit more angle which exactly at 45 degree, right? So yeah, so the little blue line means the angle is less than. So if I say for, let's say, for blue line, for blue line theta is less than 45 degree. For black line theta is greater than 45 degree, right? And for the red line theta is equal to 45 degree in any projectile, right? If we want to achieve the maximum range, the projectile angle should be 45 degree. That's the main point that I'm pointing it here. Otherwise, if we so in the olden times and still the sniper, right? So if he has to to achieve a maximum range, or any artillery man that we want to achieve the maximum range, the angle of projectile or of the cannon need to be at the 45 degree. Okay. If it is lower than that, the action will be lower. If it is above than that, it can be very less range as compared to the same. All right. So this is a comparative thing that we will going to look at. Tomorrow we are going to do some in detail the projectile motion, and then move to our force and mass equations, equilibrium, tension, and other subjects. I think I have mentioned in here. So forces, Newton laws, circular motion, and momentum. We will do day after that. Okay. We will see some more questions related to projectile tomorrow. All right. Sorry. Let me find. So I will give you these notes today and yesterday too. Uh, then let me do one thing. File. Yeah. Okay. I will save this one and the previous one, right? And I will send to you these things. And for your homework, yeah, I remember I have given you some homework that you have to list the questions from the past, which are related to, even though I have grabbed all those questions here. So mostly these are the past questions paper, and which I found it on the internet. Make some notes of those solutions which I can get, and I will give you some more questions related to the same projectile, some sort of projectile, and the linear motion, the other part of the linear motion. Okay, I'll give you some like 5, 10. You have a Skype head? Okay, try to find some questions over there and see if you can find one. I do have online version. Let's see if I can get something there. This one. Let's see if. mm, okay. So this is the motion. Can we increase the size? So this is the motion, right? Page 126, 127. Okay. Motion. So we have done this already. Scalar, vector. We already know that. Yeah, there are certain questions related to this, right? Mostly we have done all the kind of thing. Two bodies are facing each other. Try to figure it out that if you know some of the questions or not, right? Yeah, try to do that thing from the Skypad, and let's see if you're able to solve them, not solve them. Try to attempt them. If you have important, we will discuss tomorrow. All right, so let's do that. All right, see you tomorrow, 6:30. All right, have a nice day. Oh, sorry, good night. All right, cheers, bye.